And in this video, we're going to look at two problems from your mini assignment one. And the point and purpose is to give you some insight as to what is it I'm expecting when you're giving a solution back to me. And and hopefully this helps you to articulate your reasonings and to put them together in a very, very clear and a precise form. Okay, so let's look at problem 1A. Now, problem 1A is asking you that no one has lost more than $1,000 in a lottery. So what I want you to do, the first thing is, let me articulate these things on my slide here. So first thing I'm going to do is you're going to tell me what is the domain. Okay. So what I'm going to do is let me kind of here is everything on the left is just for my explanation purposes, and everything on the right is the actual solution. So what's on the right over here is the answer that I'm looking for. But here's how I'm going to explain things. Okay, the first thing is you're going to look at the domain. Second thing is going to tell me what the actual predicate is, and the third thing is you're going to tell me the actual expression using propositional logic. Okay, so the entire logic, propositional logic. Okay, so what's the domain here? Now, again, there could be different answers here, but one constraint that is really, really important is that you're going to give me predicates that only has up to two, up to two variables. It could be a predicate of one variable, it could be a predicate of up to two variables, but do not make a predicate of three variables. Okay, so first thing, what I'm going to do is I'm going to say in this problem, I'm going to have a domain, and let's say my first solution could be I have a domain of two things. So I have a domain of all people. Okay, that's my first domain, and my second domain here is of all monetary value. Okay, what's my predicate? My predicate here is I'm going to say, let's have a predicate L of x comma y, and I'm going to define this. It's really important that you define your actual predicate, and the definition over here is that x has lost y dollars playing the lottery. So you must clearly define your predicate. And my predicate here is L. I'm defining it that in this case, the way this is interpreted is that X has lost Y dollars playing the lottery. Okay, and now the actual solution. So the actual solution over here is again, let's assume that there is some X out there. There's some monetary value Y out there, such that as long as Y is greater than 1,000 and L of X comma Y. Okay, so this tells you there's some X out there, there's some Y out there, that as long as Y happens to be greater than 1,000, then X has lost $1,000 in the lottery. But the question says there's no such X out there. So you're going to take the entire thing and you're going to negate this. Okay, so there's no such X out there. And the last part of the question is give me in simple English sentences the negation of this expression. So the expression that you came up with, this is the actual solution. This is the actual solution that you came up with before you performed the entire negation. This is the question. This is the answer to the question that's been proposed. Now, the negation of this is negation on the entire box, which means that this is equal to some x, some y. Now, I'm not asking you to do this, but I'm just going to put this down right now. All I'm asking you is to tell me in simple English sentences, what does this imply? So this is, again, someone has lost. Someone has lost more than $1,000 playing the lottery. Okay, in the next video, we're going to look at one problem from your assignment, and that should be it.